Hello everybody, very good day. Today I am going to discuss about bioreactor and its parts. At first I would like to ask, what is bioreactor? Bioreactor is an apparatus for growing organisms under controlled condition, used in industrial processes to produce pharmaceuticals and vaccines or antibodies. It is also used to convert biomaterials into useful byproducts such as bioconversion of biomass into biofuels. Therefore, based on its definition, if a biology-based reaction goes on in a shake flask, on that case, the shake flask can be told as bioreactor. So in this case, you can see that the shake flask is also considered as the bioreactor besides the very huge bioreactors as can be seen in the pictures. So size and shape of the bioreactor can be varied tremendously, you can see. So the below are the very large scale bioreactors. So the first one on the left side on the top, you can see that shake flask, this is couple of ml, and the bottom one, this is actually several million per day capacity for bioethanol production. So this is very huge, you can see. Okay, today I am not dealing with the bioreactor types. However, the types of the bioreactor need to be discussed, not discussed actually, need to just mention. So these are the stirred tank bioreactor, air-lived, packed bed, fluidized bed, photo bioreactor, membrane bioreactor, rotary drum, mixed bioreactor. These are the many different, and you can see in different books and online contents, the reactor types can be found in many different way. So don't be confused. Okay. So anyway, as parts of bioreactor are the point of interest today, therefore stirred tank bioreactor has been taken as a model today. My discussion will be based on the biostat bioreactor from Sartorius, a leader in this area. So this is an old model of biostat bioreactor. It might be from year actually 2010 to 2014 somewhere there. It was actually very common in the different labs. Okay, this is the controller. So now I am going to present a video on biostat bioreactor. The video was collected from online content and integrated here. So this is the video presentation. You can see that the microbial package, these are the different parts of the bioreactor, and this is the 2-liter volume. So cooling fingers, laptops is also needed. So different tubing materials installation, so silicon tubes, different sizes. This is the guidelines. Okay, this is we need to cut it, and then the connect tubings to the cool water and hot water, and also for the pressure and draining cooling water out at the ambient pressure. So these are the diagram. You can see gas in, gas out, and then this is the agitation motor, how to connect. You can see that how to connect the agitation motor. Then power supply. After that, need to check whether power supply is okay or not. Ethernet connection to the PC and the machine. After that, heating blanket. Then the temperature probe need to be connected. This is the different parts assignment to the head plate, and this is the exhaustion cooler on the head plate. Insert temperature probe in sleeve. After this, pH probe, and then DO probe. You can see the different probe are looks different, so don't be confused. Cooling finger. Settings. These are the tubings for the filters to exhaust the gases from the cooler condenser, actually, condenser, and from the sparger. Okay, so this is only the one-way filter. This is the manual sampler, need to be mounted on the vessel, connected to the to its ports. After that, this is the corrective, that means the pH controller for the acid and base dosing. So in the acid and base dosing should be connected in the 4-way coupler. Now installing the agitation motor, then this is the culture, then the heating blanket. After this is the pH probe is getting connected, DO probe is also getting connected. Now the tubings to the motors are being set. It should be set clockwise. Okay, then the cooler in and out, then the cooling in and out. So this is altogether the fully assembled biostat A plus. This is A plus. Actually, A plus and B stat, the overall the vessel assembly is same. Only the controller connectivity a little bit different. Actually, almost it is very similar. Okay, so now differently we are showing the different parts. Here you can see that these are also example of stir tank bioreactor, different stir tank bioreactor with their parts. You can see, okay, these are the different parts. This is the head plate. Okay, this is the head plate, and different props. So these are the many different parts. It is being shown here, and this vessel is 2.5 liter, and the previous in the movie clips the vessel was 2 liter. Okay, so this is another example of of a stir tank bioreactor with the different parts. Okay, so you can see the different impellers. There are many different impellers. You're supposed to know. This is the motor. You can see already we show in the movie clips. What is this? This is baffle. Okay, this is the baffle, and then from the left here you can see that three parts. The left one is that inoculum culture and transferring device. The center one is the rotor or shaft with which the motor will be connected and the impeller will be set. Then the right one is that temperature probe. Then you can see from the left, number one is that level probe, and from the left 1 2 3 4 5, number 5 is the antifoam probe. Usually level probe and antifoam probe actually works together. Sometimes single probe can work, sometimes two probe together is being used. Okay, so usually the shorter one is the level probe and the relatively longer one is antifoam probe. Okay, number two from the left, number two is the condenser, number three is the sample collection port or pipe. Next one is that pH probe. This is the pH probe. Already I have told that this is antifoam probe. This is the sparger. This is the extra port. Can be used different purpose such as culture inoculation. This is the four-way probe. This is very necessary for, can be used for acid-base dosing to control the pH. Okay. Now the port assignment for the parts are presented here. You can see that these are the schematic diagram for the universal 5 liter. This is actually from 2 liter to 5 liter. That's why it is called uni. Huh? So this is the head plate. Different ports are being shown on the head plate. Okay, so this is the N to N16. So some of the parts can be set interchangeably, but some of the part cannot be set interchangeably. Okay, so this is very crucial. So for that one we need to have another detail clips with which we can show you that how the different port can be used interchangeably. So this is that the overall you can see that from N1 to N16 that how the different parts, you can see that the sizes is also a very big issue. Okay, so different size, obviously the part can be set on N4. Obviously anyway cannot be set at N3 or N1. The N1, the part can be set on N1, cannot be set on N2, N3, N12, N11, N9. So you can see. So this is one of the things you need to keep in mind. Okay. So this is the overall diagram of a head plate. Okay. So information, pictures, and movies are collected from the different online contents, and then it was compiled by me. So that's it for the presentation, very brief actually presentation on the different parts of a structuring bioreactor. So thank you very much. Stay safe. Bye.